Okay, now I realize I started too early. I need to explain to you what similarity means. Can you remind me what something congruent is? If two things are congruent, what can we say about their shape?
They're identical.
They're identical in shape. They're also identical in size. Similar means they have the same shape, so all angles are the same, but they can be different in size. So one is smaller than the other, one is bigger than the other. Similarity of figures. Because of the definition of similarity, we know any two figures are similar if all of their angles are the same. Or this one's tricky. Or if the corresponding sides are in proportion to each other, which means that the shapes are just resized. So you're looking at this example. Do I have two triangles drawn here? What have I labelled the sides of this smaller one? A, B, and C. What have I labelled the sides of the larger one? X, Y, and Z. What I'm saying is if they're in proportion, if I compared A to the same side on the larger triangle, so A over X, the result of that number should be exactly the same as B over Y, should be the same as C over Z. Now, if the algebra doesn't make sense, we could do it with an actual triangle example. What side corresponds to the 3 length in the bigger triangle? What'd you say? Someone said it real soft. 6. So, do you agree that if I compared 3 over 6, what is the matching side to 5? 10. So 5 over 10. What is 3 divided by 6? Half, 0.5. And is 5 divided by 10 also half?
Yes.
So that's this situation. They're all in proportion. What is that saying? This triangle is half the size of this one.
Would you please be able, do you have a practice test?
They're up. I don't have them printed.
Oh,
They're attached to Dama.
okay, and is the science test from the week before? Or is it also the science test from the week before?
The science test, that's still a while away.
Oh, thank goodness. Okay.
So does that make sense that this triangle is half of the larger one?
They're not similar because both sides.
Oh, sorry, yeah, you're right. I didn't double that. Let's pretend that that actually said 8. I doubled all of them except the bottom one. Okay, I'm not going to edit that. We'll leave that in. Thank you for correcting me. Told you, I'm not perfect. All right. So can you get that example done with the corrected 8, please? My bad. This video I'll attach to the other class's lesson as well. Alright, let's go over the proofs for the similarity of triangles. Sorry for accidentally starting on that last time. Like you can see, I should have explained what similarity was first, which I've done now. So how do we prove that two triangles are similar? If I know that all their angles are the same, that is a reason. Angle, angle, angle. Second one, and this is same as in congruence. We had a side angle side for congruence. But in congruence, what did the sides have to be? The same length. Similarity. They're not going to be the same length because one's smaller than the other. what it's going to be is they're in the same proportion. So x1 over x2 is going to be equal to y1 over y2. So side angle side for similar triangles is, one of the angles is the same, the included angle. Let me have that, included. What do we mean by the included angle? Yes?
The angle that is corresponding to the one in between the two sides.
Good. So included angle means it's between the two sides that you know, and then the two sides are in proportion with each other. The other reason for similarity of triangles, side, 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 but not sides all the same. In similarity is that the sides are all in proportion. Then the last one we had, right hand side, again, like congruence, but this time it means you have a right angle triangle and the hypotenuse and one other side are in proportion with each other. Can you get those reasons for similarity down, please? They should be on your cheat sheet. And then we'll do some examples. Anyone still on this left board? Stop now, further hold your peace. So if you're still getting those reasons down, that's fine, I won't erase them. Why is this useful? Because when proven to be similar, knowing that the sides are proportional, we can use that to solve problems using two-column proofs. So that's what we went over last lesson. We have a situation here. How many triangles do you see in this drawing?
2.
There's more than that, technically. Oh no, actually. Yeah, just two. Using similar triangles, find the length of x. This question in your book has no labels. You're allowed to add your own labels. Could we just do A, B, C, D? So the convention in maths is to go clockwise when you're labeling. So I'll start from here, A, B, C, D, E. I'm not going to mark you down if you don't follow that convention. You just need letters to refer to. Using similar triangles, find the length of x. What ways do I have here to prove that two triangles are similar? I've got angle, 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 side, angle, side, 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 right hand side. Are any of these right angle triangles?
No.
So cross that off. I'm not going to use that one. Side, side, side. Do I know how long all of the sides are?
No.
No, not going to be using that. I might be able to use side, angle, side, or angle, angle, angle. Anyone predict which we could use? You don't have to know to start off with. Be willing to play around with your toolbox, yes?
I mean, side angle side?
Side, side, side.
Yeah, you know side, side, side because it's shared.
Yeah. No?
They're not sure. You know this, you know this, you know nothing about those sides. I'll give you a push in the right direction. Is this angle the same in both the smaller and the larger triangle?
Yes.
So you could say angle BAE is equal to angle. What's the same as BAE in the larger triangle?
DAC.
DAC or CAD, doesn't matter, CAD. Why? Because given or shared. I'd never had a class that told me shared, but in some cases I like shared better, okay? I say given because it's drawn like that, but it's also shared. That angle is in both triangles. What do you notice about this? What do these two arrows mean?
Parallel.
They're parallel. So in that little toolbox that you had and you went over in previous years. Is this a line that goes through two parallel lines?
Yeah.
Is this also a line that goes through two parallel lines?
Yeah.
Yep.
So what can we, there's a label for it. It starts with a C, for this angle being the same as that angle.
Corresponding.
Corresponding, good. So I can say angle ABE is equal to angle ACD because corresponding. My little lawyer self here, I'm trying to argue angle, angle, angle. Have I proven angle, angle, angle yet?
No.
I've only done two. So I need to prove this one too. So I've used the same friggin' argument. Angle AEB is equal to angle, what? How do I say that? ADC because corresponding. But my favourite part of this topic is that there's multiple ways to do that. I don't need to use corresponding because if I prove that two of the angles in the triangle are the same, what is the angle? How many degrees do the angles of a triangle add up to?
180.
180. So I could also have said this is equal because the angles in a triangle add up to 180 degrees. Multiple ways to prove that. Now that I've shown this, what can I say about triangle? So I'll go therefore triangle ABE is similar. How do you write similar? It's a wiggly equal sign to triangle ACD. How does that help me find what x is? Because sides are in proportion.
So
So
I was going to say, so then you could do x over x plus 12 equals 15 over 24.
excellent. So what he's saying is, if we've proven that they're similar, AE should be in proportion to that whole thing. So AE over AD should be equal to EB over
DC.
DC. That should be a true statement because they're similar, but we've got labels for those things. So now I go comma. What is AE on my little diagram?
X.
X over thing. It's not just 12.
X plus 12.
It's the whole thing is x plus 12 equals, how long is EB?
15
Over.
24.
What do we do when you've got a fraction on either side of an equal?
Cross-multiply.
Cross multiplication. There's a reason why we taught that. So times that by that, times that by that. What's 24 times by x? 24x is equal to, careful now, I'm timesing by a complicated set of terms. What should I put around those to keep it good? So it's going to be 15 lots of x plus 12. Expand that, 24x equals 15x. I don't know my... Someone help me here?
180.
180. Do I have x's on both sides? I can't solve something if I have x's on both sides. So what's the opposite of positive 15x? So if I took 15x from that, what am I going to have? I think it's 9.
Yeah.
9x is equal to 180. What's 9 doing to x? So what's the opposite of that? Dividing. 9's going to cancel. X should be what?
20 centimeters.
20. That's your answer? Can you get that example, Justin? We proved similarity. We used the fact that they were in proportion to find the unknown. Why is that more useful than congruence? Because I don't need the freaking triangles to be the exact same size as each other. Okay?
They know they're the same shape.
You know they're the same shape. You assume that they're the same shape.
I tried to snatch one of his, but he was too quick.